Good morning, everybody. How are you all? Today we are going to talk about the least square regression line. So here I go. Least square regression line. As the name implies, least square means lowest value of square of some quantity. So square of a quantity, like if you think of a number 2, its square is 2 times 2 is 4. So we are keeping the square of some quantity to the lowest possible value. And the meaning of the regression word is we regress, we are falling back. What are we falling back on? We are falling back on the data points that we have collected. So let's take a look. Okay. Compute the least square regression line. So we are remember last one when we talked about correlation, we talked about relationship between X and Y. Sometimes it happens that all the paired data points, that is the pair value of X and Y, all these points are clustered around a straight line. Okay. So that's your regression line. So we want to find the equation of this least square regression line. That is the line around which all the data points are clustered. So this is the same data point as before, the data set as before. We have square feet of houses inside square feet area and their selling price. You would expect that as the square feet, which is the x independent variable on the horizontal axis, as it increases, your y value, which is the price, also increasing. Okay, so there's a positive relationship between x and y. And all the x, as you can see, you can imagine the data points are clustered around the line, close to a line which is going up the hill. So the objective of this section is to find the equation of the line. What do I mean by equation of the line? We find the relationship between x and y, a straight line relationship. And the two quantities that we are interested in are the slope and the intercept of the straight line. The slope gives us a value of how much is the change in y of this line, of a point on this line per unit change in x. That is, if we shift x by 1 unit, that is, go from one point on the line to one next point on the next point, which is separated by 1 unit on the x, how much is y changing? That is the slope. And the other characteristic of this line that we are interested is the intercept. Where does the line intersect or cuts the vertical axis, as you will see? Okay. So this is the same data point as before, data set as before, as I told you, which we plot. We made the scatter plot on our TI-84 calculator. Now look at these two lines which can be made to fit between these points. One point is going up the hill, one line on the left going up the hill, one line is going down the hill as on the right. And in both the cases, the points are clustered around the line. In the one on the left, the distance of the blue data points, which are the original paired data points, the distance of the original pair data points from the line, the vertical distance, the dashed red vertical line. So look at the point on the top, extreme top right, the red dashed line coming from it down to meet the actual fitted line. So what do we notice on the left? The vertical distance of each point from the fitted line is lower, on the general lower than the one on the right. Look at the line which is going down the hill on the right. The vertical distance of each of those points, the paired data point, the blue point, the vertical distance is the dashed line. For the points which are on the top of the line, they're coming down from the point to meet the line. And for the points which are below the fitted line, the vertical lines are going up to meet the fitted line. So what are they saying? The figures present scatter plots of the previous data, each with a different line superimposed. It is clear that the line in the figure on the left fits better than the line in the figure on the right. And what is the reason for that? The reason is the vertical distances. Remember, the vertical distance is given by dropping a vertical line from the point to the fitted line. For points which are on the top of the line, the vertical line will come down from the point to meet the fitted line. The red dashed line, for the points which are below the fitted line, the vertical line will start from the blue point and then go up the dashed line to meet the fitted line. The reason is the vertical distances are on the whole smaller on the left than on the right. The line that fits best is the line for which the sum of the squared vertical distances is as small as possible. This line is called the least squares regression line. So again, what is a least square regression line? It is drawn in such a way that the sum of the squares of the vertical distances of the actual data points from the fitted line is the lowest. What is lowest or least? Sum of the squares of the vertical distances of the points from the line is the minimum. So that's why it is least square. The sum of the squares of the vertical distances of the points from the line is the lowest. That's why the term least square regression comes from. Okay. Given ordered pair x and y, the sample means x bar and y bar, the sample standard deviation sx and sy, the correlation coefficient r, the equation of the least square regression line for predicting y. We want to predict the value of y or forecast the value of y from x is y hat. Notice y with the thing at the top called y hat. What does it mean? It's the predicted value of y. Equal to B0 is the intercept where the line cuts the vertical axis, y-axis, plus B1x. What is B1? B1 is the slope. What is a slope? As I said, how much does y change for points on the line per unit change in x? These are the equations for B1 and B0. We do not have to memorize the equation. We are going to use the calculator. The variable we want to predict, in this case is selling price, is called the outcome or response variable, sometimes called the dependent variable. And the variable we are given is called the explanatory variable or predictor variable or independent variable, which is the horizontal axis. So what are you going to do? We are going to predict the selling price of a house based on its square feet inside the house, which is the independent variable. In the equation of the least square regression line, x represents the explanatory variable or independent variable, and y represents the outcome or response variable. Okay, so again, these are the data points. This should be in our calculator. We want to get the equation on the bottom of the screen, y hat equal to 160.1939. This is the intercept plus 0.0992 is the coefficient of x, number in front of x. That is the slope. So let's see how we can get it. We will not go through these calculations. So again, we press the stat button, then highlight calc on the top row, that is move the cursor on calc, and then scroll down to number 4. Scroll down means bring the cursor on number 4 and hit enter. Okay, your X list is L1, Y list is L2, and you bring down the cursor, the black rectangle, on calculate and hit enter. And on your screen, you'll find the equation of the line. Here, y equal to, this is y hat, calculator does not give us y hat, is equal to ax. A is the coefficient of x. How much is it? 0.0992, same as what you see as the coefficient of x in this screen on the bottom. 0.0992x plus b is the intercept, is 160.1939, same as what you see on the screen. Okay. And they show you how to do it by the calculator. Okay. So here is the another data set. The following table presents the percentage of students who test positive proficient in reading and the percentage who tested proficient in mathematics. Notice proficient in reading is the first column, proficient in mathematics is in the second column. For each of the 10 most populous states in the United States, compute the least square line for regretting math proficiency. You want to predict the value of y, which is the second column for predicting math proficiency from reading proficiency. This is the x. So how do we do that? We have to enter the data in L1 and L2. L1 is x, L2 is y. X is proficiency in reading, y is proficient in math. So first thing you do is clear the memories of the calculator. So what do you do? Second button, plus button on the bottom right corner on top of enter, second and then plus and then number 4, clear all this, done. Then stat 1. In L1, I'm going to first enter the first column, which is X. 60, 73, 75, 66, 75, 79, 79, 73, 67, and 71. On the right, then press the right cursor button on the top right corner of the calculator to move the cursor to the first line in L2, where we are going to enter Y values, which is the second column of data, as you see on the screen. So 59, 78, 70, 68, 70, 77, 76, 66, 64, and 73. So we have the X and Y values. At this point, we can make a scatter plots to see the trend in the data. So what do we do? So you'd press the second button and then Y equal to. Then number Y equal to is the top key on the top left. Okay, second and Y equal to. Then number 1, X list is L1, Y list is L2, type is a scatter plot. Then we press zoom 9. Zoom is the third key on the extreme horizontal row of keys. And we see a trend going up the hill. So there is a positive linear association between X and Y. We need to calculate the R correlation coefficient and the equation of the least square regression line. So stat, highlight calc on the top row, then number 4, linreg AX plus B, and we go down to calculate and hit enter. And first we look at the R, 0.837, fairly close to 1. So it's a strong positive linear association between X and Y. What is the equation? Y equal to 1.04. Notice the slope is positive. As X increases, Y also increases. So 1.0414X plus B is negative. So the actual equation is Y equal to 1.0414X minus 5.273. Okay. Ooh, I didn't get what they're getting. Let me make sure my numbers are correct. Stat 1, maybe I entered one data point wrong. 60 and 59. Okay, 60 and 59. Okay, then 73, 78, 75, 70, 66, and 68. Then 75, 70, 79, 77, 79, 76, 73, 66, 67, 64, 71, 73. Then stat, calc, 1. Stat, calc, and then number 4. Linreg AX plus B, calculate, enter. And now we get what they are getting. So Y equal to, my slope is 0.8226, X plus B is 11.03. R is 0.808, a strong positive linear association between X and Y. So as they said, you can use the least squared regression line to make predictions. So you can plug in the value of X and predict the value of Y in the equation. So they're using it to predict the selling price of a house, which is 2,800. Point to note, the first data point on the horizontal axis, X value is around 25 something. And the last X value on the horizontal axis going up the hill is 33. point to note. So lowest is 2550 maybe, and the highest is 32. We want to predict y for x equal to 2800. This x falls inside the range of the given x value, between the lowest and the highest value of x in the data set. Hence, we can use this equation to predict the value of y. We will just multiply 0.0992 times the square feet and add the product to the intercept to get the predicted value of y. Okay. In the house data, average size is this, and the average, if you know, plug it in, we'll predict a predicted y hat. So in general, what did we find from here? That if you plug in the average value of x, you will get an average value of y. In general, the least square regression line goes to the point of averages. Interpret predicted values, the slope and y-intercept of the least square regression line. Okay. The predicted value y hat can be used to estimate the average outcome for a given value of x. For any given x, the value of y hat is an estimate of the average y value for all points with that x value. So they're using it again. Remember, the highest x value was 3800. So we want to find the y hat for 3000 square feet, which is within the range. We get 457.8. What does it mean? That the average selling price of a house with 3000 square feet will be 457,800. Okay. In the y-intercept is the point where the line crosses the y-axis. This has a practical interpretation when the data contains both positive and negative values of x. In most of the cases we deal with, we do not have positive and negative values of x. So in that case, the intercept does not have any practical meaning. If the data contain both positive and negative x values, then the y-intercept is the estimated outcome when the value of explanatory variable x is 0. If the x values are all positive or all negative, then the y-intercept b0 does not have a useful interpretation. And what is the meaning of the slope? If x values of 2 points on a line differ by 1, 2 points on the straight line differ by 1, their y values will differ by amount equal to slope. This enables us to interpret the slope b1. If the values of the explanatory variable, that is the x value of two individuals, differ by 1, their predicted y values will differ by b. If the values of the explanatory variable differ by amount d, that is x values differ by d, then their predicted values or y values will differ by d multiplied by the slope. Okay, two houses are up for sale. One house is 1900 square feet and the other is 1750 square feet. So what is the difference in x values? 150. So how much will their prices be differ? 150 times the slope. So 150 multiplied by the slope is 14.9. So we predict the prices of the house, which differ by 1500 square feet in the size, will differ by 150 multiplied by the slope, or $14,900. Okay. At the final exam in statistics class, the professor asked each student to indicate how many hours he or she studied for the exam. After grading the exam, the professor computes the least square regression line for predicting the final exam score from the number of hours studied. The equation of the line is y hat equal to 50 plus 5x, where x is the number of hours studied. Antoine studied for 6 hours. What do you predict his exam score be? 5 times 6 is 30 plus 50 is 80. Emma studied 3 hours longer. How much higher do you predict 3 score? So the difference in x values is 3. The slope is 5. So 3 times 5, 15. So Emma's score will be higher than Antoine by 15 points. How did I do it? I found the difference in x values is 3, multiplied it by the slope, which is 5 in this case, 3 times 5. Hence, the predicted y values will differ by 50. 15, 1, 5. Okay. So there you go. I'll stop here today. If you have any question, comment, write me a note. Please do write me a comment. I respond to each and every comment. If you like this video, please give me a thumbs up. This really motivates me to produce more good videos. Okay. If you like this video, share with your friends, you and your friends. Please subscribe to my channel by hitting the red subscribe button at the bottom right corner. Let YouTube know that you'd like to be notified every time I upload a new video, which I do almost every day. So please do not forget to check me out tomorrow when I'll be back with another interesting video. Thanks for watching. Take care. Have a nice day. See you next time.